According to this question, there's a uniform rod whose length is 200 centimeter and the mass of the rod is given to be 500 gram. And there are two masses, one is 2 kg, one is unknown mass m, and they basically try to balance each other so that the system remains in equilibrium. So this question based on torque. So in this system we are supposed to find the value of m such that the rod is in equilibrium. What does it mean? It means that this particular mass has the tendency to rotate, to let the system rotate along the anti-clockwise direction. This particular mass has the tendency to let rotate the system in the clockwise direction. But if the system is in equilibrium, it means it is not rotating, which means the total torque or the net torque will be 0. So net torque on the system is equal to 0. Then who are contributing torque? This particular mass is contributing torque because of its weight. This particular mass will also contribute to torque because of its weight. But this particular rod which is mentioned, it also has some mass, 500 gram. This will also contribute to the torque. Now this is the point of balance. Therefore the total torque in the right hand side should be balanced by total torque in the left hand side. So anti-clockwise torque will be balanced by the clockwise torque. The center of mass of this particular rod will be somewhere here because the length of the rod is 200. So this point will be 100 point. This point will be 100 point. Therefore this will be 0.5 multiplied by g, which will be the weight of the rod, which will be applicable here. Now about this particular point we have to calculate the torque. So the total amount of torque should give us 0. Therefore this torque should be balanced by this torque with the torque contributed by this particular mass. Let us first calculate the torque due to 2 kg. It is equal to the weight of the body, which is 2g, multiplied by the perpendicular distance. In this case the distance is perpendicular because angle is 90 degree. So this distance will be 40 minus 20, which is equal to 20, multiplied by 10 power minus 2, because it is given in centimeter. Anyway this will be cancelled. Then the torque due to this particular force, it will be equal to 0.5 g multiplied by 10 power multiplied by this distance is 100 minus 40 is 60, multiplied by 10 power minus 2 when we convert it into meter, plus torque due to this mass multiplied by acceleration due to gravity. Then from 40 to 160, what is the distance? This is 120 into 10 power minus 2. So this g 10 power minus 2, these things will be cancelled. This will be equal to 40. 0.5 into 60 will be 30 plus m multiplied by 120. So if I solve it, the answer would be equal to 1 by 12th. So that's the answer. Here in this question, there is a circular ring whose mass is m and the radius is r. The corresponding to a 90 degree sector is removed from this particular ring. The moment of inertia of the remaining part of the ring about the axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then what is the value of k? Now according to the question, let's say this was the ring whose mass is m and the radius was equal to r. Okay, and then a quarter of the portion of the ring is removed. So it will be like this. So this is the remaining portion and this is the removed portion. Now according to the description of the question, let's say the ring was rotating like this. It was rotating about an axis which is passing through the center of the ring and perpendicular to the plane. In that case, the moment of inertia would be mr square, that we know. Since moment of inertia is scalar quantity, it means that it can be added like scalar, and because both remaining portion and the remove portion were moving following the same common axis. So let's say the moment of inertia of the remaining portion was equal to I dash, and the removed portion is, let's say, IR. So when we add the moment of inertia of the remaining portion and the moment of inertia of the removed portion, it should give us the total moment of inertia. Now, what should be the moment of inertia of the removed portion? Removed portion is 1/4. Therefore, its moment of inertia will be 1/4 times the total moment of inertia, because moment of inertia is a scalar quantity. So this is equal to the moment of inertia of the remaining portion, which is mk square according mr square multiplied by k according to the question. This is 1/4 mr square. If we solve, what we will get is that it is 3/4 mr square. So mr square cancel. Answer is option 1. Let's move on. This question is based on transformer. It says that a step down transformer connected to an AC main supply, which is 220 volt. Supply volt means this is the primary voltage we have to consider. And then this transformer is made to operate at 11 volt. That means this should be the demand of the output, and the power is 44 watt. So a lamp, it is supposed to be connected on the output, and the output demand is that 44 should be the output power and 11 should be the output voltage. So what we know is that, let's say this is the primary coil. Here our 220 voltage is there. Let's say primary current is IP, and the output power according to the question, it is 44 watt. Ignoring the power losses, if the power loss is ignored, then the input power should be equal to output power. And under this case, what will be the amount of current in the primary circuit? That's the question. So let me write down the expression for the power. Vp multiplied by Ip equal to 44. Vp is 220 multiplied by Ip equal to 44. So Ip will be equal to 44 divided by 220. So answer will be option 1. Thank you.